That's it, right? Huh? Okay. Hey guys, how are you?
Doing good.
Hey, can you guys hear me?
I can hear you in Tucson.
Vegas, I can hear you.
Who else is on the line?
It's Chris in Colorado Springs.
Okay. Can you hear me? Okay, Chris?
Yes, yes.
All right, we're going to get started here. Help from any one of you guys? So obviously. So before we start, all of you should have the Spot program installed on your machine. Did you guys have a chance to check it out, whether it was installed or not?
I got this is Mike in Tucson. I have it on my computer, but I haven't, other than opening it up, I haven't tried to use it on a project or anything, no.
Okay. Anybody had any?
I thought we needed administrative privileges to load it on our machine.
I'm sorry, what?
I thought we had to have administrative privileges to load it on our machine is what I heard. This is Alan in Vegas.
Right, and if you don't have that administrative privilege, just send an email to Bob or Steve Barnes.
Okay.
And he will have it loaded on your machine.
Okay, will do.
Is Denver on the line?
Hey, Prim. Yeah, Prim, this is Casey, Tim, Jodell, and Ted are all on the line here. I know Jodell, Tim, and myself all have it loaded on successfully. I don't know that Ted has gotten it loaded on yet.
Okay, great. Okay, talk about theory. Most of you have gone to Revit training. Probably the first one or two sessions are really boring because they talk about theory. You want to get yourself into the program and start clicking all these buttons. But the reason why I want to spend one session on the theory is this is more important before you try to understand the tool. The important part is why do we need to use this tool, and what are we trying to solve? It's the why is the question, and if we understand the why question better, then the tool part, learning the tool part is really easy. Because the tools change every now and then, we have to learn new tools. So this is going to be on the why part. So hopefully on the next session, we will go through each and every single step, every screen of Spot. Does that make sense? Okay?
Yep.
All right, let's get it. Okay, so today we're going to look at an overview of what we looked at last week. I just want to point out a couple of things. And we're going to talk about what visual comfort means. And we're going to talk about daylight harvesting, the holistic approach. And we will use Spot and what we can do. Finally, I have a exercise for all of you to do as well. All right, let's go to the next one. Okay, so last week we looked at conceptual energy analysis and conceptual performance. These are the 6 key performance indicators for any high-performance design. We're going to look at visual comfort today. So our intent is to validate all of this in our project. Go to the next one. So the process that we talked about was to take responsibility, ask appropriate questions, set metrics, and we're going to talk about metrics related to visual comfort today, and validate our design, and then tell the story. The important part here is why you did what you did, and we often don't do that, or we seldom do that in our design process. We just talk about what our design is, but we don't write a story about how and why you did what you did. I think that's what I would like us to focus. So we looked at several tools. Today we're going to look at Spot. Go to the next one. What would be the ideal process of using all of these tools? Go to the next one. First step that we want to use, first tool that we want to use is Equus or IESVE or Autodesk Green Building Studio to find our energy consumption and peak demand. And once we know that, it will give us a chart something like this. this will tell us the breakdown of different energy consumption in our building design. So immediately you can say lighting, this is for a typical office building here in the United States, lighting is about
I'm actually doing this spot training WebEx.
So immediately we know that that's where the problem is. If we can do passive strategies to bring this down, that's where we want to focus our efforts. So it's important to start with this and understand where your energy is. Yes?
That's specific. You said that's across the U.S., so that's going to vary depending on what region.
Yes. Yep, exactly. This one is, I think this one is for the whole country. Our region will be totally different. If heating or cooling is higher, then we want to focus on passive strategies to bring that down first. Before we start applying technologies such as chillers, all that stuff, we want to use passive strategies as much as possible. So when it comes to lighting, we want to start with daylighting as passive strategy. And then we'll use our tools to validate occupant comfort. We're going to talk about how to validate visual comfort today. So then the ideal process would be to fine-tune our design and redo this as an iterative design.
For someone just put a comment, can you have everyone mute their...
Yeah, certainly. Could everyone mute their phones, please? So if you have a question, please unmute and ask your question. So, and then rerun the model at the end. And this is an iterative design process, and I think we can the next one. So, this is something that I didn't cover last week. We have to do because of these reasons. Energy codes will start mandating these. And energy modelers as a whole discipline is starting to be a really big deal in the industry, and we don't want to lose another opportunity. But the important part here is this journey is going to be really technical. We have to start learning many new terminologies. There's no way around that. Okay, so that was just an overview of what we had last week. We're going to talk about visual comfort today. So the definition of visual comfort comes from quantity of light and quality of light. Do we have adequate light levels? So that's where the quantity comes into play. And then quality is, do we have balanced light and do we have glare? So if you're providing, bringing in daylight is very easy, right? Just put a bunch of windows and you call it a day. You brought in quantity of light. That's very easy to do. But this is the part that's very difficult. The quality part is the difficult part. How do you balance the natural light in that space? How do you control glare? So every design that we do, we typically try to put in windows and bring the amount of daylight into the space, but we never check for how balanced it is. Right? And that's what we're going to do with this program. So how do we measure all of this? How do we measure quantity and quality? For quantity, there are several different measurements. We can measure it at a single point in time, which is what LEED asks you to do. LEED wants you to measure it at 12 o'clock and 9 o'clock in the equinox. So that's one way to measure it. The other way to measure it is daylighting autonomy. I'll talk about that in detail. But daylighting autonomy is an annual measurement, which is more applicable to the design than a single point measurement. Can anyone say why? Why do we want to do an annual measurement of light levels than just one single point?
It takes into account both summer and winter. I mean, it takes
into account not only different conditions, but it also incorporates clouds and cloudiness and sky conditions from the weather file, which is important to understand for your daylighting design. The idea behind single points in time is they choose equinox, which is about the middle. Sun's altitude is in the middle from summer solstice to winter solstice. So if you design for equinox, can kind of handle both winter and summer. So this is the easy way to do it, single point. Daylighting autonomy way is a little difficult, and Spot is one of the few programs that can do it. When it comes to quality of light, to see if the light levels are balanced in a space, again, there's a single point in time method or minimum daylight autonomy. What does balanced light mean? So let's take this space, for instance. If our activity in this space is reading, then let's say it requires 50 foot candles of light, regardless of artificial light or natural light. Let's say it's 50 foot candles of light. We kind of have a balanced approach, right? We have daylight coming from the left and from the right. There might be some low light levels right in the middle here. The minimum, the quality of light in a space is only achieved when there is enough balanced light. So the measure that we're going to talk about for that is minimum daylight autonomy. We'll talk about what that is. And then glare. When do we get glare? High contrast, yes. So, and those are notorious for that, right? If we don't have proper shading, we're going to get glare. So there are different measurements. Daylight glare index is something. Is a method that uses logarithmic equation. And there are programs that calculate the daylight glare index, like IESVE. There's another method called the max daylight autonomy method, which is what Spot uses, and I'll talk about what that is. So the first one, quantity of light in terms of Spot. So they use a method called daylight autonomy. What daylight autonomy stands for is the percentage of time over a year. So it's annual, over a year, at which daylight can provide a given illuminance for a given point. So what that means is, let's say, for instance, this space, we're designing to 50 foot candles. Then daylight autonomy, let's say if it says 50% daylight autonomy, that means 50% of the entire year, this space receives 50 foot candles. Does that make sense? Because if you do it if you use the single point method, you would only know whether this space achieves 50 foot candles at any given point in time. So you would have to do that at multiple points in the year to understand the daylighting in the space throughout the year, which is where daylighting autonomy comes into play. So that's very, very important that we start using daylighting autonomy to understand the full impact in a year. So in this example, 50% daylighting autonomy for 70% of a south-facing classroom means 50% of the time the design achieves 50 foot candles at 70% of the floor area. Does that make sense? The reason why I'm going through this is once we use Spot, the final output of Spot will be in these terms, in these terminologies. So we should be able to understand and see if it impacts our design. Okay, let's go to the next one. As far as achieving balanced light, the minimum daylighting autonomy metric is to have 60% of any space over a year achieve the daylighting autonomy. So if you have a tiny window in a classroom, for instance, you will achieve the daylighting autonomy for the year, maybe for just 10 square feet of your room. But that won't give you balanced light unless you achieve that over 60% of your room. That makes sense?
Mm-hmm.
So in that example, 50% daylighting autonomy for 70% of the south-facing classroom. So you're able to achieve more than 60%. So that should provide balanced light. When it comes to glare, the daylighting glare index is it's a number from 10 to 28, and above 16 is uncomfortable. But that daylighting glare index is difficult to predict because it actually depends on the viewing angle and the amount of light in the source and the amount of light in the scene. So it's very difficult to predict that from every single standpoint. So the way max daylighting autonomy works is it just puts a limit to the amount of light that can come into a space. For instance, if we design this space of 50-foot candles, then they put a metric that says 10 times of the minimum design luminance. So 50 times 10, 500-foot candles. They're saying at any given time in the year, if there's more than 500-foot candles in this space, then that could cause glare. So they want to limit the amount of time lights more than 500-foot candles. Does that make sense? No? It does? Okay. I guess this is an easy way, because the problem with glare is it really depends on the viewing angle, right? If I get a glare on my computer screen, if I tilt my computer screen, I can reduce the amount of glare, right? So it's very difficult to predict glare in a classroom. So this approach says if you don't bring in a huge amount of light, then you're potentially reducing the amount of glare without taking into consideration the angle of perception, the angle of view, because that is very difficult to predict. Does that make sense? So the metric here is no more than 5% of the space can have more than 1% max daylighting autonomy. So again, 1% max daylighting is 1% of the year cannot be more than 500-foot candles. If more than 1% in a year is more than 500-foot candles for more than 5% of the space, then that space is not glare-free space. That makes sense? This will start more.
So up next to the windows where you're going to have your most 500-foot candle.
Right, and that's a good point. The glare is measured at the work surface. So even though you're going to have glare looking at the window, we want to look at the work surface.
Yeah, I know, but will your 1% be more along the window line, or it won't make it all the way into the classroom?
Right, and that depends on if you have shades and how deep your room is. Yes. Yes. Yeah, if you go back one more time. Yes, that's a fantastic question, because not every building will be occupied throughout the daily hours, right? So within SPOT, you will specify your occupancy schedule of what you expect that building is to be occupied. That max percentage will be off of the number of hours that the building will be used. So if your building is only occupied during the morning, you don't have to necessarily control glare in the afternoon. So we're going to analyze all these three with SPOT. Again, SPOT stands for Sensor Placement Optimization Tool. So before we get into SPOT, I just want to go over an overview of daylight harvesting as a technique. So most often we find ourselves just bringing in daylight and we stop right there. Because we don't finish the circle. We don't control the artificial light, and we don't evaluate energy saving. Unless we do that, it's pointless to do daylight harvesting, because we're going to be potentially increasing the amount of cooling because of the amount of windows or amount of heating. Unless we evaluate all of that, it's pointless to do daylight harvesting. So what is the process? First and foremost, we've got to start defining daylighting zones in our buildings. If it's a classroom building, it's pretty easy to define daylighting zones, right? All of our classrooms need daylight. But if it's a deeper footprint building, it's important to define how far we want to daylight. Then our fenestration design will change based on how far we want to daylight. And this is something that will force interaction. How many of us know what light levels are required for each space activity in our building? We don't, right?
Just some narratives.
Huh?
Usually there's some pretty electrical narrative.
Right. So if we don't know what kind of light levels we're required to have in a space, how can we design? So we should coordinate with our lighting guys, and they have a handbook called Illumination Engineering Society of North America, right? IESNA, and that dictates all the light levels that are required, or recommended light levels for specific activities. So then, knowing that, I wouldn't recommend jumping into Spark right away. I would recommend using rule of thumb calculation to come up with your fenestration design and balance it with aesthetics and other important things in the project. And then validate it. Right? But before you go to that, how many of us think about light fixture design while we're designing the space? Sometimes. We should start doing that more. In order to achieve a balanced daylight, a balanced design, balanced lighting design, understanding the light fixture design is very important. For instance, if you figure out that you can't afford more than 20 square feet of windows in a classroom, then the back end of the classroom is going to be pretty dark, right? The light can't penetrate that deep. So understanding what type of light fixtures are we using to offset that, and can it balance the natural light is very important. We should start doing that more. Then we can validate visual comfort using spot. Using spot, again, understanding controls is very critical, because certain light fixtures can only be controlled certain ways, right, depending on the type of ballast that we choose. So it should be an integrated approach. We try to understand how much energy we can save. So we need to understand controls too. As architects, we need to understand controls, as well as light fixtures. And then, finally, it will help us evaluate energy savings. Not only just from the amount of savings from turning off the light, but also from heating and cooling. So this should be the ideal daylighting harvesting process. How often we do this? Not that often. Okay. So I just put in some rule of thumb calculations. These are directly from LEED. LEED tells you, depending on how far you want the light to reach, it tells you a window to wall ratio. And I'm not going to labor on this, but it's on the LEED book if anyone is interested, to do rule of thumb calculations to try to figure out how much window you need. That's for side lighting. This is for top lighting. This is another book that most of you will be familiar with, Mechanical and Electrical Equipment for Buildings, the LEED book from school. Again, this is just a rule of thumb to understand how big of an opening you need. And typically, all of these rule of thumb calculations will yield you more window square footage than you need, so because they have a lot of factor of safety into it. So keep that in mind when you're designing. Okay? So far so good?
Yeah.
Yep.
Okay. Any questions so far, anyone? Nope? Okay. So we'll look at SPOT. Basics of SPOT. So there are 6 steps in SPOT. And I will probably go through those 6 steps if we have time today. I think we do. And show how the program functions. But in general, the first step is to define your performance criteria and define just the project folders and general project information. So that's pretty easy to do. The second step, this is an advanced step, and that will help you determine shading devices. Say if you have blinds, and if you can control those blinds, you can specify what angle those blinds should be calculated at, and get a little complicated. So I would find most often I wouldn't get into this step. And the third step is this is the critical step. This is where we would input geometry, not only for the room as far as the windows and stuff, but also for the light fixture. So again, this is another step that will force combination between lighting and architecture, because we have to choose what light fixtures that you plan to use in that space. This goes back to the balanced design that I talked about. And then the fourth step is understanding where the just telling Spot where this space is located, and the occupancy schedule that we talked about, and what kind of shade control we have on product. And then the fifth step is that's where we analyze all of these different aspects of the building. So the fifth step will tell you the performance of the artificial light alone at night without taking the daylight. And then it will tell you the daylight performance. Finally, it will also tell you where to put your photo cell, photo sensor, to take advantage of all the aspects. And then finally, the analysis section, that's where it will tell you how much energy you're going to save. So before going into the sixth step, I would see us using this fifth step. We would have to go back and forth to try to see if we meet those visual comfort goals right here in this design two step. Does that make sense? It will make more sense when we get into the program. This is just a simple output of what Spot prepares as a report. And as I talked about, it's kind of hard to see here. It will tell you if your design has adequate daylighting or poor daylighting or overly daylit. It will tell you that report right here. And I'll go over some of these metrics in detail. So before I jump into it, does this seem like a program that will help our design? So do these metrics make sense? Daylighting autonomy, minimum and maximum daylighting autonomy for both quality and quantity? Okay, good. Guys on the phone, do you have any questions before I move on to showing what Spot can do?
Not on my side, none on Mike and Tucson.
Okay, great. I'll take a look. I'm going to just show sample project. Okay, so as I mentioned before, Spot is an Excel-based program. Can you guys hear me on the phone?
Yep.
Okay. Spot is an Excel-based program, and it has a lot of macros. So every time you open Spot, you want to do this, enable the content, so that you can have macros functioning. And as I mentioned before, if you recall from the last week's introduction session, Excel is just the front end. On the background, Spot uses a program called Radiance. And that's the engine that crunches all these different formulas. So I'm just going to show you an example that I did yesterday. Okay, so this is the first step, and there are a bunch of different code types that you can select, and I'll go over them in the next session. But for this quick show and tell, I'm going to use Spot daylighting autonomy. So once I begin the process, this is the screen where I can input all the geometry information. So I'm just designing one classroom with a window, with a clear story window, two clear story windows, and one vision window. 30 by 30 typical classroom. So typically the work plane that we measure the performance is at 30 inches from the floor, normal table height. And these are some default information. But again, if you have a thicker wall, maybe an ICF wall or a thicker wall, that will have an impact. So it's important to go through all of these defaults. Again, surface reflectances, this is a point where it forces coordination. The default here is 25% reflectance of the carpet or the floor, but nobody checks actually what carpet we specify, so we should start doing that. This is a good place to check all of that different reflectances.
Where do you get that information from?
It should be in our specifications, and as we pick and choose different materials, finishes, we should know what reflectances those things will have. Okay, if not, how do we find out? There's got to be a way to find out the reflectances of the carpet and floor, right?
I would think so. It's just not.
Okay, so we'll dig deep into that, but there's got to be a way that we can find out what that is.
Yeah, I don't think it shows up like on cut sheet information or anything.
If you're not talking, I mean, it could be terrazzo, it could be concrete.
Right.
So it's not always carpet.
Yeah, a critical percentage, like you get on a ceiling tile, is it just a matter of darker light?
The challenge with the floor, as I understand, is it won't affect the quantity of light, because that truly depends on the window opening, right? But it might affect on the quality of light from a contrast ratio. So I think we'll have to play with it to see if it makes a difference in the space.
As we change selection, how dark is it?
So,
You have to kind of dig those numbers up.
right. So the process that I would suggest is we start off with the default and let our design. But once we select a product, once we specify a finish, then we'll have to back check to make sure that we are within the range of. If there is a significant change, then we may want to rerun this analysis back to our design.
Those are the numbers that we
Yes. Do you guys use that? Right. On their lighting programs, they use these baselines. So this would be a good cross-check to see if they use the same assumptions that we have on spot. So not only the physical geometry of the space, but also the openings in the space, and I'll go through how to get into this. But you can specify if it's translucent glazing or if it has blinds and shades and things like that. And it'll also tell you the amount of windows from a window-to-wall ratio standpoint. So, and then finally, also select the light fixture that you're trying to use in the space and its layout as well. And this is where we need help from you guys from the lighting design standpoint. For this example, I've just used a generic direct indirect light, but for our designs, we can coordinate with our guys and try to find the actual ones that we're using.
Have you ever tried to actually put an actual IDF file in there?
Yeah, and I can show that in detail in the next session, but you can select a file with an actual IDF.
I've tried it.
It didn't work out?
Not figure out.
Okay, we can focus on that next week. So once you do this, then this is where it asks for all the site and usage information. You can talk about the weekly schedule and an annual schedule. Now I'll get into more detail of how to manipulate this for different occupancies. And then once you do that, This is the nighttime work plane illuminance. This is the amount of light that will come out of just artificial light at night. And here's where we specify if the required amount of illuminance. So it could be 50 or it could be 40, depends on the space. For a classroom, it's 50 foot candles for reading.
Are you saying at night?
At night, meaning assume there's no daylight coming in. So as a first step, we always want to make sure the artificial light is sufficient to take care of the lighting requirements, and that's what this screen will tell you. So according to this design, the light fixtures that I have is not enough because the max is only 45 foot candles, and if I have a 50 foot candles requirement, the light fixture design is not right based on the fixture that I selected. And which is very critical because daylighting goes hand in hand with artificial lighting. Yeah, so right here, this is the length and width of the room, and it shows you, yep. Because I had the layout somewhere in the middle, or focused on the middle, so it's kind of lower on the side. And so once you move from there, this is the daylighting result, and this is that fifth step that I talked about, design tool. This is where we can understand for clear sky during winter at 8 o'clock in the morning, that's your distribution of light. And you can understand how your light at 12 o'clock is really cool because of all that light that penetrates deep into the space. At 4 o'clock, again, you have very good exposure. So that's a clear sky, and you can just go through all of these different things to understand what is happening in your project. But this is where it gets critical. And to understand the daylighting autonomy, you want to click View Report. And here it will say poor daylighting, because I changed my requirement from 40-foot candles to 50-foot candles, right? And the reason for poor daylighting is annual quantity of daylight is low. I might have changed something here. So it could be any number of things. Increase the number or size of openings, or adjust the glazing transmitter. So this is really a helpful tip to solve the problem. See, the light fixture is only for nighttime. So for daylighting, they're only daylighting solutions. That's what we're trying to get at. And then the next step is we'll integrate daylighting and artificial lighting and put a photocell and try to find out how much we can turn off. And that step will take a lot of time to crunch the numbers. Not a whole lot of time, but maybe a minute or two. But we can get into that in our next session. But if this is our design solution right now, it says it's poor daylighting. So we can go back, and for instance, instead of 40% transmittance, let's say I go 50%. And on the second window, I go 50%. Third window, it's already 60%. That is. If I go through the process. Between steps, it will take a few minutes to crunch all these numbers. That's what I changed. Yep. And I did select that as a translucent glazing material. So the more windows we have, more time it takes to crunch all these numbers. But to understand one classroom, this took me like 10 minutes to put this in. Wouldn't this make sense to do this on many of our designs? So I typically just back and next enter all that stuff, and then I go into view. Still says read. Now it's right. So it needs some kind of shading. So again, I don't want to get into detail. We can get into this detail next session. But in general, that's how I see we use this program.
Just change the Windows program. What is determining?
Hey guys, sorry to interrupt. Is someone's mouth breathing into their phone?
A little Darth Vader action going on.
Yeah, if you guys could mute your phone, that'll be great.
Sure. Star 6 works if you're conferenced in.
Oh, it could be the projector.
No.
Okay.
I don't think so.
All right. Is it better now? Okay.
Yes. Yes.
So what is that threshold? What is that thing that makes it as overlighting? That's this percentage. So the max daylighting autonomy, as we talked about, should not be more than 10%, 10 times the amount of foot candles. So see, right now my maximum foot candle level is 3,000 foot candles. I'm receiving 3,000 foot candles.
So because you set yours to
50, so 50 times 10, 500 foot candles. So apparently more than 5% of the floor area is receiving more than 500 foot candles for more than 1% of the year. That makes sense? Because right now there's no shading of any kind.
You said you're going to teach us no shading?
Yeah. So, right. And so that's where in the geometry input section, that's where you can add shading elements to it. So instead of a window, you could have an exterior overhang or an interior light shell. And yes, I think you can do fins. Yeah, I think we can do fins, but I'll investigate that. But the problem here is, as you can tell, this won't work. This program won't work for non-rectilinear spaces, right? Because it needs a length and width. As soon as you move away from that, this won't work. And no, we didn't use this program.
Is there any program?
Yes.
Okay.
In order to get into that complicated geometry, we need to use AGI 32. And the problem with AGI 32 is it can do all the complicated geometry, but it cannot do a daylighting autonomy study. It can only do single point in time. So you see the difference? We'll have to manually check several different times of the year to see how the light would be distributed in the space. That's what this program does. But unfortunately, this one doesn't do geometry, complicated geometry.
So if our interior wall has got a certain amount of borrowed light coming in, does it factor in a different level of illumination than does an exterior wall? Same thing with the solar tube. Does it factor that light at a different percentage level of illumination?
All we see is one volume. All we explore is one volume. Even though it's an interior wall, for spot, all we're trying to say is one volume, right? Enclosed volume for illumination.
Yes.
So it doesn't really matter if it's an interior wall or exterior wall. It just looks for a volume. And then when it comes to solar tubes, we can model it in a couple of different ways. We can model it as a skylight, as an opening on the roof, or we can model it as an artificial light, right? As an artificial light.
Okay.
Because it does come with come with an IES file that tells us how the distribution will be.
I didn't see anything for those under the aperture lens.
For for solar tubes?
No, yeah.
Instead of a window, you could have a skylight. Is that what you're asking?
Yeah, I mean, it allows you to add those categories in, right?
Right. So you can use the window on the roof, on the ceiling. So that'll be a skylight. Now, I'll go over all of this in detail next session. But is this something that we think we can use?
The jails are pretty square, so yeah.
Yeah. And sometimes our fenestration design might have, we might be looking at different solutions that, for instance, Ted had on the Agua Fria school project. He has a classroom that faces west, and the best way to stop west sun getting in is to put something in front of it, right? There's no way to simulate that using spot. We'll have to go, because spot, everything has to be connected to a surface, right? I have to be off of that south wall. It has to be connected to that wall.
Yeah, there's another program to make that more complex geometry.
Correct. That's where we would use AGI 32. So that the challenge here is we can trick the system somehow. For instance, what Ted was thinking to do as a solution was to put a grill, perforated metal panel in front of it. Let's say it's 50% open. What we could try to simulate would be to have the visible light transmittance of the glazing to take account of that opening. Let's say we have a glazing that is 60% visible light transmittance, and if you put a perforated metal panel in front of it that's 50% open, then we could simulate this as if the glazing transmittance is 30%, 50% or 60%, just to understand how it will work.
This to help with energy consumption as well as, occupant comfort?
Yeah, this will. So right now all we looked at was the max daylighting autonomy and minimum daylighting autonomy and the amount of light in the space. So that takes care of the visual comfort standpoint, right? I'm bringing in enough daylight and I'm bringing in quality daylight. So if this report says adequate daylight, then you're achieving visual comfort. And in terms of energy savings, we have to go to that sixth step and that's where we will place the photocell and figure out how much lighting savings we'll have, including cooling and estimated cooling and heating savings.
We have to do this for every single space in our building.
Every single typical space. So if you have a whole bunch of classrooms facing south and they share the same geometry of window openings, then you only want to do one. But the moment you change angle of one of the wings or something like that, then you want to see if you need additional fins to solve that problem. Does that make sense?
Yeah.
Most often I'd see in our buildings just 4 or 5 classrooms to test. And that should be enough. And if it's an office building, corner offices typically have worse glare problems with 2 windows on either side. We can test those things. Okay? So finally, it's time. I just want to leave you with one thought. So that's our homework. Let's each one of you select one of your projects and come up with 3 questions that you want to ask Spot. And Spot will tell you the answer. So come up with 3 questions. Huh? I think that's it for today. So for next week, most likely we will. I would like you guys to have a look at the Spot program. Just open it up and see what it looks like, and play with it. next week, most likely, I would encourage you to sit at your desk and use the program while we're going through this. That makes sense? Instead of just listening to me, so that you can just play with the program while I'm going through the button pushing stuff. All right?
Thanks, Prem.
Thank you.